Okay, on TEAC 7.6a, when we hit the rollovers on elements and compounds and atoms and molecules, it's wanting us to distinguish between those two. So, distinguish between elements and compounds and between atoms and molecules. So, for me, it's very easy to get the words molecules and compounds mixed up or use them interchangeably. And honestly, at this point, I would say that this is something I'm going to hit with my students, but I'm not going to do a lot of intervention to them for them to know the difference between a compound and a molecule. There is, let me see, this little graphic here that's a great visual for them. So an atom is just a single element. They can point to it on the periodic table. Um, but if we combine more than one atom of an element, we get molecules or compounds. If the elements that are being combined are the same, that's a molecule. A compound would be two or more different elements that are chemically bonded. So I really would want them to distinguish between a single atom versus atoms that are bonded together. And we call those either molecules or compounds. But I wouldn't put a whole lot of stress on them having to remember the difference between the two. The last part of the TEAC has to do with chemical symbols and formulas. I do think it's interesting to note that the TEAC's guide mentions that some elements are not going to have symbols that match their element name and to talk about why that is. And then in the IUP is linked just a vocabulary anchor chart that kind of pulls everything from this TEAC together, that you have atoms. Atoms are found on the periodic table, and they make up elements. Elements combine to make compounds or molecules, and those compounds, molecules or elements can be represented by a chemical formula, and that goes into the next TEAC. Okay, for 7.6b, we are looking at the number of each kind of atom in a chemical formula, and they do note that students should know be able to use subscripts and parentheses when identifying elements and figuring out how many atoms of each element there are. So this is when at our training we use Legos or we use snap beads or M&Ms. We used all those things to model chemical formulas so students could build them. And it starts simple here, and it's broken down into the element, molecules, and compounds. Notice this says molecule of a compound, so a compound is still a molecule. Anyways, but you could even make this into a card sort if you wanted to. But they can use the element or the Lego blocks over here to build elements, molecules, and compounds. And this should be pretty simple. If you give them a few examples, then they should be able to drag the different Lego pieces using the key, and they'll need a little pre-knowledge about subscripts before they do this. But there was the engage activity that we did. It doesn't have to be office supplies, but any supplies that you can give them in a baggie or something, and then they can come up with some formula or symbols and numbers that represent what was in the bag. They don't have to get it perfect, but afterwards you can introduce subscripts and chemical formulas and have them rewrite a chemical formula for their bag that has letters to represent the object and numbers to represent how many. So doing that first should give them that background knowledge for the subscripts here to where they can apply it on this slide. Then we want to get into actually modeling it with hopefully something hands-on in 3D. And we're going to get into more complicated examples. Students do always get confused when there are two capital letters together like SO4. Lots of the times they want to apply the 4 to the S as well. So one of the first things I always have my students do is find a capital letter, all your capital letters. If there's a capital letter without a subscript, I have them draw a 1 next to that capital letter to remind them there's one of those. Anyways, so we are modeling this as well. If you have a dot cam, this would be a great time for you to do it along with them to start with. Under the dot cam, you're doing it, they're doing it at their table, and then they're going to do some on their own, check it with you before they do it all on their own. So when we get down here to the parentheses, again, I want students to be able to see what this means before we start just teaching them to multiply. So I would have them model anything in parentheses. There's 2 of them. So we have, again, there's no subscript next to the capital C. I would have them draw a 1 there. So that means I have 1 carbon. They can kind of, it tells us right here, carbon is yellow. So they have 1 carbon, 3 hydrogens for red. So that's CH3 in the parentheses, but this 2 outside the parentheses means there's 2 of those. So they're going to build it a second time. And it doesn't really matter. You could build it like this, or they could build it linear. Either way is fine. So I have 2 of those. Then my last capital letter here does not have a subscript, so that's like having a 1. So I just have 1 nitrogen. And that's how I would model this. Now, then I want to maybe do it I want to do it the same way again with the next example, just so they get it. But they should be able to count now to fill out their chart of how many atoms. Oh, I have 2 yellows. That was 2 carbons. I have 6 hydrogens. And then I had 1 nitrogen. So I would have them build it like that again. So for this example, barium, they're going to have to make their own key here. So I'm taking a little bit away. They're going to have to list the elements and make their own color code, which it doesn't matter what color they pick. And then they're going to have to build it. But whatever color they pick, I have 3 BAs because there's a 3 for a subscript. Now I'm going to build what's inside the parentheses. So PO4. And I'm just picking random colors right now. They'll have to make their own key. PO4, 1P, 4 oxygens. Now, the 2 means I'm going to repeat everything in the parentheses a second time. So I'm going to do PO4 again. Oh, you know what? Sometimes you can just do like this. Nope, it's going to copy the whole thing. Okay. So we're going to build PO4 again. Now this makes it easy for them to count how many atoms were in this compound and how many atoms of each element were in the compound. After this, I would want to have a discussion about, well, how can we do this faster than building it and writing it out 2 and 3 times or whatever it says in the parentheses? And somebody in the room should be able to pick up on the fact that, oh, I could just multiply what was inside by 2 instead of building it twice. And eventually that's where we want to get them to, is to where they can just multiply the 2 times each of the subscripts in the parentheses. So I had a 1 here for P, a 4 for O. So I would do a 2 times 1, or I'm doing 2 times the little red block, and 2 times the green blocks, or 2 times the 4. Okay, some of your students that get stuck at this point, if they can at least get the modeling part down and understand why it looks like that, that's fine. If some of them don't ever get to the multiplying part, if they can model it, that's great. I wouldn't even be opposed to giving them physical models to use on the test. And then for this last slide, we're taking away the models. Again, if they need them still, that's fine. And they're doing things more independently. They're having to list out each of the elements by finding them on the periodic table. And then they're having to tell how many of each one, how many of each atom there is in the chemical formula. And then here they're going to total up the total number. So you can see here I had a 2 for the iron, 3 for oxygen. Then they total up all of the atoms for iron and oxygen to see how many atoms are in the chemical equation.